Thank you very much. Good morning, everyone. Let's jump right into it. I would just like to make a very quick survey to understand the audience I'm talking to. So could you raise your hand if you are specifically in the role of DevOps something? DevOps engineer, DevOps manager. Okay, not too many actually, which is surprising. Okay, then that's interesting. So let's get into it. Most of you probably don't know me, which is very understandable. So I'll just say something about myself. Who am I? Mostly because whatever I'll be talking about will start to make more sense because your life experiences kind of dictate who you actually are. So my education is from the realm of theoretical computer science / systems programming. I entered work as a consultant, mostly working for banks on top of their data warehouses, building not as a data engineer, but as an application developer. Then later on, I became a lead of a professional services organization in a small startup where I was building the organization. Right now, I'm a solution architect of an internal developer platform called CodeNow. We'll be talking a bit about this, but don't worry, I'll not be doing a sales pitch here. I'm also an indie game dev because everyone has a dream, right? So I have my own video dream. And I'm also an educator for topics related to IT for business personas. Now let's get a bit into the topic that I want to talk about. In 1913, Henry Ford revolutionized manufacturing by creating the assembly line. By the way, this is about software engineering. And as Harrison Ford famously once said, if I had asked the people what they wanted, they would have said a DevOps team to deploy for us. Essentially, a lot of things when it comes to companies can be kind of timed back to here. Because a lot of things that we do and how companies work are really based on assembly lines. It is an area where one team has one responsibility, and a team is responsible for doing their one piece, for making a car wheel, for making a steering wheel. No longer do we have an entire team of 100 people doing everything. And it's the same in software engineering. The bigger the company, more likely, the more separated and fine-grained it is into specific products and services and microservices and so on and so forth. You can even see it in non-technical departments. Very often in HR recruitment processes, very often the team managers who actually are going to be working with the people are not the ones doing the recruitment. Very often they're actually at the end of the recruitment pipeline, and at the end they finally have a say. And it's the job of an HR recruiter to understand everything about the market and what the manager actually wants. Whether good or bad, this is where we are. So to kind of put this together, we also need to talk a bit about the history of DevOps. And we need to go back to no longer 1913, we're going around to 80s or so, where personal computers still were not that much of a thing. However, software development already was. And the model that was most dominant became the waterfall model. These days, you can very often hear things such as, waterfall sucks, agile is the way to go. Then following that, you hear that agile is the worst thing that was ever created. But that's not really a topic here. The important part is that waterfall is the perfect assembly line situation. It's the moment where each stage follows the next. You have an assembly line where somebody builds the requirements. Then you have someone making a prototype. Then you go ahead. Then you give it to the user, and the user is shocked that they are not getting what they wanted. So here we're already looking at the assembly line process. And operations is just a custodial function. It's just a function at the end of the assembly pipeline. Essentially, dev is doing something on one line, then they walk to the next line and give the box to the ops person to follow up. And what are they measured on? Well, dev, what do they want to do? They want to deliver features, which means they want to maximize changes. Essentially, what they're doing is as unstable as it can get. On the other hand, the operators, are measured on ensuring stability, on ensuring uptime. And ideally, in the ideal world of an operator of these times, there would never be changes. They want to maximize stability. So you already get this kind of a big clash of two completely different assembly lines working together, and obviously what you get is the blaming game, where the dev team is going to tell the operator that they configured it wrong, that they deployed it wrong. And the operator is going to say, well, you wrote it wrong. The documentation doesn't make sense. The definitions don't make sense. This just doesn't work based on what you did. So you're here in the big blaming game. And what that means is that we're the market had to solve this somehow, and that led to the rise of agile methodologies. I'm not directly saying that it had to be the specific implementation of agile as we currently have it, but the bigger part of it was to deal with the uncertainty of development, which led to a massive speed up of dev. Suddenly, dev has access to CI, automation of SDLC, no matter if companies are actually able to do that or not. However, the ops teams didn't really have anything such as that. They were still separated. Still, any deployment was done via ticket. Still, the release cycle was done by big bang releases, and so on. So on one hand, the assembly line that's on one side is faster. However, the other assembly line is still there and works the same. So that's not really leading anywhere. Now we are living in the world of web scale. Very often, software engineering is synonymous with web development, actually. And this model of 2 assembly lines, in an ideal world, I'm saying that it was ditched, but the more I see the market, the more I see that that's not the case. But the philosophy here should really be that. And DevOps became a movement. And that movement is to say that dev and ops should be, in reality, part of the assembly of the same assembly line. That's really what it is. And it's important to note here that at this point in time, DevOps was not a term for a specific engineer or for a certain role in a company. DevOps was just a feature of the team, its quality, that they follow a philosophy, that they're able to be fully end-to-end owning a certain tool. So in an ideal world, what that should lead to is that release cycle is faster, that there's no longer a sysadmin bottleneck, that ops team is not drowning in tickets and so on and so forth. I'm not really going to go through all of these because you know them. But the big portion of here is the term that you may easily find called fragmented delivery. Fragmented delivery is essentially the point where what you're trying to achieve is not something that you're able to do yourself. And very often, a beautiful example is on Amazon as a shop and as Kindle. Imagine if Kindle somehow had to depend on the web store to do anything with Kindle. It just doesn't make sense. But in reality, in companies, very often an engineer needs to make a ticket to a DBA or an ops person to get access to a database, to get access to a repository. Then they need a new instance of a database to actually deliver a feature and so on, to run testing. And essentially, DevOps as a philosophy is the answer to software engineering solidifying and no longer working like a 1913 factory. I also will say, even though commonly these days the term is DevOps engineer, even if it actually fits the philosophy or not, because many companies, as we'll see, don't do that, I will be using the term operator, simply because these terms are very often confusing, so that will be the term used. So we need to talk about why this is the case, and what follows here are organization structures. This is a, let's say, organization structure which may exist, and it's the ideal organization structure to never get out of this hell. Because what you're getting is that you have an R&D team that has to do delivery, or other development, and a team related specifically to delivery. That's related to infrastructure and everything else. And it does feel natural if you think about it. But if you do it this way, if a company works this way and this is the team layout, then you're inherently never going to get out of the separate assembly lines. You're never going to be able to work together. Where did I leave this here? And that leads me to Conway's law. There's very few things in software engineering which are actual laws, as in physics laws of physics. But Conway's law tends to work very well. And this, by the way, is a different Conway from the Conway's Game of Life. Now, essentially, the major thought of this is that communication in software mirrors communication within an organization. So let's say that you have an e-commerce shop. If you have a team responsible for handling claims, which is a part of customer service, you're probably going to have a software module called customer service and a software component for claims. It's just natural. So why does this matter? Well, very simply, because if this is your organization structure, that's how your software is going to work, not only within, but also related to the delivery. And very often these Conway's Law talks are related to microservices and business topics, but even directly within software engineering, within, for instance, 3D development, I really like this example taken from Casey Muratori. This is a legacy simplified hierarchy of Microsoft's DirectX, And you can directly see that there were libraries for, or header files for music, sound, draw, direct 3D. And that's not simply because they decided that those are going to be the modules, that's because there was a team specifically working on 2D and specifically working on 3D. That's specifically how they came to different header files for public API. So what that means for us is that if we rebrand ops into DevOps, while still retaining this organization structure, we're not really achieving anything. We can't. We simply cannot. There is no way to change anything. So, as a result, development is one assembly line, delivery is another. Deployment is done via tickets. You are achieving the exact same delivery cadence because the other team can't really do it faster and change anything. You're running into the same issues. So you must change your organization structure. You cannot throw whatever tools there is, whatever Terraforms, whatever Ansibles, whatever Argo CDs, if you're still working in this separate way. So how to become DevOps? Once again, as a philosophy, not as a specific role of a single person. There's many ways, and actually what I do recommend, Atlassian themselves, even though most of their materials are very difficult to read related to their own tools, they have a great set of articles on DevOps and the philosophy of it, and how to become DevOps as a DevOps culture of a specific organization. But most of it can be boiled down to these three areas: automation/infrastructure as a code, enabling continuous delivery, and working on culture. That really is the biggest thing. And I'm not really going to be discussing infrastructure as a code here. I believe that other presentations today are a much better fit for the technicalities. But what I would like to say, what really drove some understanding here, not just about automation and speed up, was that manual deployments almost always fail. And dependent on the number of manual steps, it is falling fast. So this, for instance, is a graph I discovered. And it turns out that even with 5 manual steps, your deployment is going to succeed at 86%. And that falls down really fast. The more and more of them you have, the less likely it is you will be able to install whatever version that you're trying to set up. So then continuous delivery. Now, once again, toolchains, technicalities, not really a topic for this presentation. It's more important to consider it as a function of your organization's capability. Now, it's important to know that continuous delivery is not the same thing as continuous deployment. Continuous deployment refers to simply a change is automatically deployed. Continuous delivery is the prerequisite that I'm actually able to do this. Now, obviously, we need to consider that that may not be as trivial or desirable to deploy continuously. If we're working in a highly regulated sector, we need to do secure programming, or we simply don't really want to change production very often, then we don't have to. The results are very clear from that, because what happens is that you master the process. You automate better. Your changes are smaller. If they're smaller, they're easier to handle. Your time to repair is faster. If you have to roll back the versions of the product, it is easier. Most likely, you're not really going to break experience for anyone. But now we're going to the big one, culture of collaboration. This is really the one that I wanted to talk to, because I think that this is the area where many talks I go to at various conferences and so on, or I talk to people, I feel like there's a big philosophical clash of what DevOps should really be and how it works. One of those is related to team structure. As I mentioned, Conway's Law is beautiful for this. The other one is really team behavior, how they actually cooperate together. So around 2014 or so, CTO of Amazon famously said something along the lines of, you build it, you run it. That's the team's own requirement. So that already goes down to the fact that you should have a self-sufficient, independent, end-to-end software team, a product team. What DevOps then means is really just enable IT alignment on development, operations, and processes of software delivery. All of those operations should be a part of a unified business process. What that means is that very often, Dev has their own source code management tools. Sometimes the ops teams work on them, secure them, guarantee them. Sometimes they do not, really depends. And the ops people essentially, as they work on prod, the environment is quote-unquote locked, in the sense that devs have no access or visibility to questions such as, I really need to get access to prod logs, or I need to get access to the prod DB snapshot, is impossible. Obviously, it may be impossible, it may not be trivial if there is, for instance, data that should be anonymized, fair. However, they still should somehow discover certain ways. And therefore, Alice and Bob, Alice is the developer, Bob is the operator here, should really work on the delivery together, and ops should enable this end-to-end visibility to the developer. Now, essentially what that means is that they need to work closely together, ideally as a part of the same team. This is, of course, a two-way street. I'm here talking mostly about ops, but that doesn't mean that the dev does not need to change anything in his life either. Operators should be a part of the development process, not just the delivery. Very often in Agile, this is recommended as them being essentially business users, and therefore the ideal personas for providing any kind of feedback. At the same time, however, developers should be a part of the production rollout. This relationship needs to go two ways. We cannot really say anything along the lines of ops needs to change without pointing the finger at dev and also saying that there is something that needs to be done. Obviously, as mentioned, there are certain limitations which need to be respected. Now, there are various implementations and various methodologies to work with. Agile is one of them, but there's many, many, many. The important note really is that however you implement it, frankly, doesn't matter. What really matters is that you enable the team to work this way. If we go back to Conway's Law, one of the big portions that's hidden there is that inter-team communication is expensive. Mentioned on an assembly line, if I need to take something to another assembly line, if I need to create a ticket, that is expensive. If you want to know more about various models which exist, I, for instance, recommend team topologies. But at the end, you're still going to always get the same thing, that you're looking to create a self-serviced, empowered, end-to-end product team. Very often, you get this term there called independent value stream, which is a very simple term that the product team is able to deliver end-to-end self-sufficiently without depending on someone else. For instance, as my own experience, personal experience, I can say that at one company, we were developing not really a big solution. It would have been a project for 4 months total. A month and a half was spent just waiting for accesses into Git and various databases. So one popular model that exists is a matrix team structure. We'll take a look at it. It can be good, it can also lead into traps, but there's also other models existing. For instance, in the Czech banking environment, one that's popular is the one taken from Spotify, where teams are arranged into tribes and squads, and then they have guilds and chapters, etc., etc. So this is, for instance, a matrix team structure. The idea here is that you have a product or a service or a project, and you have certain people on it, such as the developers, QA engineers, and operators. Now, the part here is that then they report to a manager, so essentially you have cross-functionality here, where they are on two teams at the same time. So while this can work, I'm not saying it can't, it's very often recommended, do note that you may fall, or a company doing this may fall into the trap where they've been before. Because essentially you can see that almost everyone is in two roles at the same time. And in the case of a dev manager, of a developer, they're not on two roles. They only report on the project. Whereas for DevOps, there's likely some kind of standardization. So when they talk to the release manager, they're now talking only in the scope of their product. So essentially they are doing two jobs at the same time, double the stand-ups. And what's going to happen is that they go to the exact same stand-ups on the project, they talk about the same things, but they're not doing the same thing at all. So if you do that, then you've essentially created a hidden shadow organization structure in the company without realizing it. Really, what's the most important part is simplifying it to the T. And what you're going to get, for instance, from BMC Consulting, they have this kind of a diagram which really simplifies it. That you should have a platform team and a product team / business system team. Now, platform team is a completely new word here that I haven't really been talking about. And we'll get to what platform engineering is. As the final word for Conway's Law here, sometimes what companies do, and what may also work, is a design where they kind of rebrand or recreate in a new way how the organization chart should look like. Because if they do that, then naturally the software should follow. because that's how the people should work. So if you, for instance, work in a company which has decided to start going in a microservices area, breaking down a monolith, very likely this is the process that they're undertaking. So if there is this kind of culture collaboration, if dev and ops really works together, then the planes become greener. You simply end up having actual independent value streams, ideally. You have empowerment of the product teams, because now the developers can handle things. Faster time to value is what you get happier developers. Those were less likely to leave the company after a year. So all of those are great things, but now there is one other hidden note here, a hidden trap, which is related to the ops team or the DevOps people actually sitting in two chairs. Because there are two areas here that they need to solve. Either they're focused on product delivery, which means they're on a product team, on a service, and they need to deliver something to production. And they must ensure that the production is not on fire. They must ensure that as an e-commerce, when there is Christmas, it doesn't simply break, etc., etc. But then I'm saying things here such as the DevOps engineer must also help the developer during the process, because the developer also needs assistance with, for instance, creating an instance of database or managing source code management, etc., etc. And this is very often a place where I also feel the philosophy of DevOps kind of breaks, simply because you're putting a person into two chairs. These are two, while closely related tasks, very different. So you're getting this prod-focused ops versus dev-focused ops. Obviously, prod ops is not really a term, or not one that I've ever come to see, but that's very often what the companies do with this DevOps role. Which leads us really to platform engineering, product teams, and so on. In many really big-sized companies, we're talking enterprises of the size of, let's say, Netflix, you're getting product teams. And the product team does have these operators, but essentially the role of an operator kind of disappears. Why does it disappear? Because under the hood, they have the platform team. And the platform people are building golden paths, the pipelines for everyone to use to guarantee security, to make sure that everything can be done the same way, that onboarding, offboarding people is trivial, building even IDP portals. So that's, for instance, what we do at CodeNow. But what we need to also understand, if you want to do platform engineering, you must be at least this tall to enter the ride, so kind of taller than I am, I guess. What that means is that your company really must have a lot of budget available, and a big reason for it, because this effort is expensive and is not related to core business. Most likely, your company's core business is not building internal development platforms. And if that's the case, you're putting a lot of money here for something that's not core to your business. And you have to put them continuously there because you need to maintain everything. As anyone doing any kind of operations, pipelines break, new versions break, new Helm charts break. I feel like Helm charts are actually the least stable thing in the world. Then you find out that this Helm chart doesn't really work on Amazon. This one works on Azure. You need to do some modifications, etc., etc. A lot of time spent for maintenance. However, there are already companies which focus on these kind of IDP portals, enabling self-service, software deployment, just having access to pipelines, delivering features, even feature flagging, various having access to artifact repositories, tagging releases, managing releases, configuration, and so on. Some of them oriented more to enterprises, such as CodeNow, but there's even some which are more, let's say, personal hobbyist level, and we're just fine. So what are the key takeaways here? So really, DevOps started as a philosophy, now became a role. And very often I come to see job advertisements, and nothing in the job advertisement is even closely related to what DevOps is supposed to be originally and what it actually solves. It just says that you need to be a person who is going to set up containers, set up pipelines, and do delivery on an ops team. And if you do that, then I'm sorry, but you're just rebranded operations into something else. The company has not done a single thing to help that. So what you get guaranteed is the endless blaming game of dev and ops kind of fighting each other. That's what you get. So if you want to unify the assembly line, the company needs to be strategic. Not just in the sense that you put tools on the assembly line. The tools can help, and do help. The tools are even a requirement. If you want to do automation, you're not going to get it without the tooling. But also, if you want to get it right and get something meaningful from that, you basically need to change the assembly lines themselves. You cannot just have two separate assembly lines. You need to kind of merge them, and you need to be at least slightly intelligent about that. At the end of it, the further you go, the more the role of the operator actually slowly disappears. And if you want to close the circle truly, you want to guarantee that one person sits on one chair, doesn't actually do 2, 3, 4 things at the same time, because what that leads to is obviously lack of focus, you're doing more errors, the people are unhappy because they're not doing what they want to do, so they end up leaving the company. Platform team is one of those things which can really help here. But at the same time, this is not just from me being from code now. I do actually believe personally that outsourcing this into a product can be immensely helpful, unless, of course, your delivery requirements are ultra-specific, but I kind of doubt that. So what you end up having with DevOps is that market results validate that you deploy faster, employees are happier, the software is better, you have less bottlenecks, and so on and so on. But it's not just about having the role of a DevOps engineer in a company with this kind of organization structure. If you just rebrand the team infrastructure or ops to DevOps, you're still in the exact same hell. And that's everything from me. If you want to talk to me a bit more, you definitely can. Here's my contacts. Or you can just come say hi to me right here. Thank you very much.